Good afternoon, everyone. Welcome in Paris. First time in Grand Palais. Raise your hands. Okay, just to have an idea. I'm Laurent Thiers from DDN, the undisrupted leader for AI-enabled data platforms. And I am honored and pleased to introduce for just a few of you who don't know Neil Zeghidouri, co-founder and chief modeling officer of KYUTAi. So Neil has been at Google DeepMind before. He was leading a team for generative audio. So this is going to be the main topic of our subject today. And before Google DeepMind, before generating audio, as you can imagine, he was actually working on understanding audio, right, for synthesis at Meta AI as well.
Yeah, thanks, Laurent.
All right, so he's the brain. Today, actually, I took back on programming a few months ago when we decided to do this talk, just to get a bit closer to your level. So today the topic is how to unleash the potential of audio, right, in the world of AI. So audio at scale is his topic. So Neil, you're going to introduce us through your journey, and I think you should say a few words about KYUTAi as well. And then in your mission in KYUTAi, what's your, as we say in French, votre but de guerre? Where is my Laurent? He's around here. Okay, he will understand. He's there. He's my buddy. And what obstacle you've been going through, and obviously we will discuss the future of your framework.
Yeah, so indeed, I'm a founder of KYUTAi. So it's an AI research lab, non-profit, that we created 2 years ago with Xavier Niel, Rodolphe Saadé, and Eric Schmidt. And our focus has been multimodal large language models. So what we call multimodal large language models is models that not only understand text and generate text, but can process any kind of signal. So that can be understanding images, generating video, generating speech, transforming speech, understanding any kind of information under any format, right? So trying to get AI not only as a text interface, but closer to the kind of models that can interact with the world, collecting any kind of information. And in that context in particular, our kind of specialty has become speech and real-time speech interaction. So we released a year ago Moshi, the first real-time conversational AI. We released the first real-time speech-to-speech conversation. So we have been working on transcription, audio synthesis. Before at Google, I created the technology behind generative audio applications that you may know, like Notebook LM. It's interactive, generated podcast you can create on the fly. And so in that context, one big difference in what we typically do in text is that you need to train large language models on massive amounts of multimodal data, which means large volume of audio, large volume of images, large volume of videos.
Wow, so let's double down a little bit on what actually makes a good voice agent, right, enabled by AI. You spoke, Neil, about transcription, right? So I think transcription is quite obvious. I think we are using it every day in our life with Office software, right? What is it about transcription, if you can re-explain?
Yeah, so when you train a transcription system, what you need is massive amounts of audio data along with the corresponding transcripts. And the current challenges about transcription are having models that can run in real time, having models that can do turn taking, so detecting when you're done speaking, for example, in a conversational setting. Models that can handle code switching. So code switching is the fact that, for example, in some dialects, people are going to mix several languages, and every word is going to come from a different language, and that creates very complex situations. So that's the kind of challenges that we have in transcription.
Excellent, thank you. So is it what you learned before in your PhD?
Yes, so that was my focus at Meta, and then I switched more to the generative aspects, which currently is kind of the most popular application in speech, which is text-to-speech. So it's generating speech from text. So you know many products like 11 Labs and others.
So speech-to-text transcription. Text-to-speech is actually synthesis, right, of the voice. So with these two, I think the audience already is getting the two facets of an audio agent. What about translation, right? Translation in real time. Is it what you said about code switching when you detect with your application a change of language?
So yeah, translation in real time is more challenging than transcription because depending on which language is the source and which language is the target, the order of the words may differ. And so a bit like a human interpreter, you need to accumulate enough context to make sure that you are pushing the translation forward in the right direction. And so trying to teach that to LLMs is quite challenging. And in particular, in that context, the big challenge is about latency. So you want a model that is accurate, but you want a model that for transcription in less than 1 second, let's say, and for translation in less than a few seconds, can output the translation. Because basically right now, the main application in translation is that you will have your earbuds and you are in a conversation. If you have to wait 5 seconds every time, it just makes everything implicitly impossible to follow. So you have all these challenges on the latency and the accuracy of the models.
That sounds like an interesting journey. So text-to-speech, speech-to-text, speech-to-text, and automatic translation. What about you will actually embrace and integrate all these models together into one framework, right? That would be cool.
Yeah, so Moshi, our first contribution was instead a speech-to-speech model. So you can make a conversational AI by having a speech-to-text, an LLM, and a text-to-speech. You're going to have mostly two difficulties with that. The first one is the accumulated latency of all this pipeline. So typically, these kind of systems, they are going to have a latency that is above 2 seconds. That means that when you ask a question to the system, you're going to wait 2 seconds to get an answer. This makes it very not enjoyable to talk to. A second difficulty is that there is information when we speak that is lost in that process, in the transcription process. That's everything about intonation, irony, emotional state, and so on and so forth. So training a speech-to-speech systems, it addresses both issues, and that's what we did with Moshi. So the latency was below 200 milliseconds, so as fast as a human, and at the same time, the model was able to understand non-linguistic cues that we vehiculate when we speak.
That's amazing. So I've been reading about the breakthrough you've done at KYUTAi, right? To integrate all this model together into this framework, right? So that's what you are using today for you and your customer to model and to implement any voice task, right? That's amazing. Maybe we should double down on the infrastructure that you've been using so far. So I think we need to compliment our good friends from NVIDIA and Scaleway. But I heard that there is another invisible hero that you've been using during your training, and the trainings can be lasting very long time, the preparation of them. And you said that you are extremely dependent on low latency access to data. So what is that invisible, or maybe not that invisible anymore, hero that you've been using?
Yeah, so when we train multimodal LLMs, storage is obviously a much bigger challenge than when we train text models. Because we need very fast access to storage, because the way it works is when you train our audio models, we train them on millions of hours of audio. When you train world models, which is a new project we are working now at KYUTAi, so it's models that can interact in simulated worlds, like in video games. In that context, you need to load massive amount of data in real time, because the GPUs are so fast to compute the forward and the backward pass that you need to have new inputs constantly ready to be processed by your GPU. And that means being able to access and read large amounts of data very fast.
So you've been using which technology? I forgot the name.
DDN.
All right, DDN. All right, choose DDN if you want to enable your AI pipeline. That was one of the key takeaways of the session today, after obviously hearing you developing a framework for any audio task. So let's maybe project ourselves in the future. And in the business future, what do you think, Neil, are very good applications of what you've been doing so far at KYUTAi, right? I would love to have, when I call the help desk, an agent that understands me, and as you said, is going to switch language, and who's going to be able to listen to me even if I am about to board the plane in a very noisy environment? Or, I mean, what are the typical business cases that you could enable?
So, in audio, there are two big applications that emerge, and we have started commercial partnerships at KYUTAi to give our technology to people who try to make products around it. And we see two different kind of use cases. The first one is about interactive conversation, so it's typically in customer care, in taking phone calls, having an AI assistant, and so on. In that context, either you want a speech-to-speech model for the naturalness, but it's typically pretty hard to deploy in production because it's much easier when you already have a text LLM that is fine-tuned, that has its function calling, its RAG, and so on, to just plug the speech-to-text and the text-to-speech. We made streaming text-to-speech and streaming speech-to-text so fast that you can get an overall latency of below 1 second, despite the fact that you have a cascade of 3 models. So this is already in open source, and you can find it on Hugging Face. But another kind of applications, it's more about creative industries. So we have partnership with the video game industries to make things like NPCs with AI voices, even funnier stuff like creating fake sports commentator in sports games. So you will play, let's say, a soccer game, and instead of the comment to be pre-generated, it's generated on the fly based on the situation. So in all these cases, you have the generative part of audio that is used, and then there are much more classical and much more mature applications of transcription, which is meeting transcription, phone call transcription, and so on and so forth. On the second part, the new project we are starting at KYUTAi around word models. So it's a partnership with a new startup called General Intuition. And basically what we are doing is we are using a lot of gameplay from video games. So it's people playing video games and with the recorded actions. And we use that to train AI to predict the future state of the video game based on their actions. And when you train a system like that, you can make generated video games based on a single image. You can take a photo from here and start walking around. And all of this, it can both create very interesting entertainment experiences, but it's also seen by us, by DeepMind, by a lot of actors, as a scalable way of training robotics in simulated worlds. So the goal is that instead of deploying untrained robots in the physical worlds and letting them fall apart and break everything on their path, training them in these simulated worlds before deploying them in the physical world. So these are the business applications that will come from our research.
Well, robotics AI seems to be a very, very obvious case. The world is changing so rapidly these days. Something hit me recently in using AI when I took back on programming. We use a prompt, right? But I think with your technology, we can use the voice and interact with these systems much more efficiently and in a much more enjoyable way, right? So I see also this as a very good business case. So you say help desk, meeting with any too many situation, a very noisy situation, robotics AI in order to command to your bots or robots. So I think the future must be extremely bright for your research and applications, right?
Yeah, so in particular for voice, what is interesting is I started my PhD in 2015, and back then a lot of people were saying that voice was already solved. Then a few years later, people started making comparison with the Her movie and that we were getting close to it and so on. Anyone who talks to an AI assistant today can say that we are very far from it. And so the gap between this and where we're at right now is still big. And so all the steps that separate us from everybody using voice AI in their daily life is improving the robustness of this system, improving their understanding of humans, improving the quality of the interaction. So that's currently the barrier to the global adoption of voice AI, and that's what we are working on.
So I told you it's the brain, and I think you will soon hopefully become the GPT of audio. So what's next then? How do you see your future, your personal future soon?
Yeah, so we'll have
New
exciting announcements pretty soon around progress we are making on our models. That spans from improving the intelligence of the speech models to having even faster transcription and synthesis, improving quality, more language coverage, But also, we explore on-device models that could run on very low-end hardware, so that you can have very high-quality voice that is sitting in your phone instead of being connected to a cloud API. So all of this is the kind of things that we have on our roadmap.
So I have a dream. Sorry. To make a real-time demonstration, which was supposed to be the case. And so next time we see each other, I swear we should do a real-time demo.
I'm never shy of doing live demos. I love doing live demos. There were technical limitations that didn't allow me to do that. Very happy to do some anytime.
All right, so please double down on KYUTAi and DDN, and thank you for your attention.